Hey, welcome to Beals Science. I'm Craig Beals. Today, we're gonna make some pH indicator out of this red cabbage. See, red cabbage is pretty fantastic. It's got that deep red color. Well, it's got some compounds in it that will change color when the acidity changes. So we're gonna explore that today, and we're gonna show you how you can do this right at home. Step one, we're gonna take our red cabbage and we're gonna cut it up. We want little tiny pieces so that we can extract the color. Now, kiddies at home, if you're gonna do this, you might wanna let an adult do the knife part. I think legally I'm obligated to say that. With our half cabbage, we can pretty well make 2 batches of our pH indicator. I got my hot water. The other thing to note is I'm not measuring because there's really no need to. If I find out that my indicator isn't dark enough, well, I just add more red cabbage. If it's too light, well, add more water. It's already turning blue. Isn't that awesome? Oh yeah. Then I'm gonna let it sit for about 5 minutes and let it steep. Let it pull all of that good purple and red color out of our cabbage. We're gonna use a fine mesh strainer. We just get the nice colors in the bottom. Should we taste it? Huh? Yeah, that's what we're saving. We're gonna start with bleach and with vinegar. The reason is I have a little insider information. Maybe it's because I teach chemistry for a day job, but we should see 2 extremes here. One of these is basic and one of them is acidic. Let's find out. Vinegar, very nice. All right, children, you want to see? Do we get the red cabbage pH indicator? Do either of you know what pH is?
No.
No. Well, we're gonna have to learn that. What about acids? No. Bases? No. Vinegar? Ah,
Oh my god.
that's pretty good.
That's like hot pink.
Yeah. Look at the difference. That's a big difference. This is bleach. Bleach.
Whoa, it's blue and green. It's brown. What? Ew.
You see it going green and then changing to red?
Yeah.
Isn't that cool?
I see it blue and then green and then red.
Now we know the beet juice will change color. We just got to try a whole bunch of different stuff and find out what colors they're going to change into.
It's not beet juice.
Oh, what is it?
Red cabbage.
Ah, I have beets too. We can try beets. We can make a movie out of beets. But this is red cabbage?
Yeah.
Thank you. Thank you for correcting me. I've got a whole bunch of household items here to test. And what I'm going to use is a pH probe to first figure out the actual pH. What do you think? Vinegar acidic or basic? There we go. 2.67. And I used the pH probe to test all sorts of stuff from around the house until I felt like we had a pretty decent range of acids and bases. A pretty decent range going from near 0 up to 14. Well, that brings up the question, what is pH? And what is an acid and what is a base? Now, I'm going to explain acids and base and pH in 30 seconds or less. Okay? Don't tune me out. We're going to start a timer. We're going to learn this. 30 seconds or less. Here we go. Well, first, what is pH? pH stands for power of hydrogen. And if you know anything about pH, you know that there's a scale. It goes from 0 to 14 with 7 being in the middle. If I have a whole bunch of hydrogen ions, those are positive hydrogen atoms, that means I've got something that's acidic. The more positive hydrogen ions that I have, the more acidic it is. And very acidic means it has a low pH number. The opposite of that is hydroxide, which is an oxygen and a hydrogen hooked together and it has a negative charge. Now, if I have a whole bunch of hydroxide ions, it's basic and it has a high pH number. Now, what about in the middle here at a pH of 7? Well, that means I have an equal amount of positive hydrogens and an equal amount of negative hydroxides. And think about this, if we put those two together, that's 2 hydrogens and 1 oxygen, that's H2O, that's water. Which is why water is neutral. 30 seconds, nailed it. Remember, the goal is to make an indicator that shows a change in color with a change in pH. So we took a spot plate and tested each one of them individually.
Pink. Oh yeah, we looked.
By putting a little bit in the spot plate and then adding some drops of our indicator. And as you can see, the indicator did respond to the changes in pH. It changed color depending on the pH. One of the things you can notice is that the higher the number, the bluer the liquid. The lower the number, the more red or pink it is. Well, then why do we get the different colors when the pH changes? Well, let's go back to our hydrogen ions, our acid makers, and our hydroxide ions, our basic or alkaline makers. You see, in the red cabbage, we have something called anthocyanins. That's what gives the cabbage its color. Let's think of that molecule as like a pigment. But there are different forms of anthocyanins. We have some that are a little more pinkish red and some that are a little more blue. Now, if we put the pinkish red and the blue together, what color do we get? We get purple. So technically this is like purple cabbage, not really red cabbage. If we put our cabbage juice in with something that's acidic, all of those hydrogen ions are going to start to take over one of the forms of the anthocyanin. It's going to take over one of the colors of the pigment that's in here, and we're not going to see it anymore, which means the other one is going to remain. So if we have something that's very acidic and it starts to take over all of the blue colors, then all we're going to see is the pinkish red. Now, the other side of that is, if we have something that's very basic and we have a whole bunch of negative hydroxide ions, reddish, pinkish colors are going to start to go away. We're not going to see them anymore. All that we have left are the blue ones. And this is why we get the changes in color, that changes in spectrum, because of those nice little pigments inside our red cabbage. There they are, the class of 2020, lined up. And once I knew the pH and the color associated with that pH, I decided to line them up with the most basic on our left and the most acidic on the right. And this is what we got. With just a little bit of experimentation, we were able to make, well, sort of the colors of the rainbow, not entirely, but I bet if you really tried at home and went out and got yourself some red cabbage and then just start mixing things with it, see how the pH changes the color, and see if you can make a rainbow that's much more beautiful than mine. Thanks for watching. Keep on learning. That's good stuff, man.